Hello, welcome back to the channel. So let's move on to the next unit right now and cover some properties of definite integrals, which would be really helpful for solving most of the questions that we'll do later on in this video series. So these are some basic properties of definite integral. You can also prove them by using some basic examples. You can also take your most favorite functions and can check why these properties hold true. But more or less, if you have to generally prove these expressions, if you want to prove these properties in the most general way, this can be done by using Riemann sums. So feel free to try it out and see why it works. Although the most important part about these properties is to get an idea about how we will use these properties in order to solve the definite integral questions. So let's go over these properties right now. For these properties, before going over these properties, we'll assume that a, b, small a and small b and capital A, B, C are all real numbers and fx and gx are my integrable functions. So if you're taking a definite integral of a combined sum of two functions or a combined subtraction of two functions, you can always split those definite integrals, as in this case that you see on the right hand side. And if you have a constant attached with a function, you can always take the constant out and solve for the definite integral for the function itself by taking the constant out and multiplying the constant at the end of your final answer. So these are the three properties that you can always use in order to simplify your definite integrals and solve for them. And if we combine all these three rules, we can see that we can take those constants out in our definite integrals. And if we're taking a definite integral of a combined sum of two functions, we can split those expressions up. So now let's move on to the last property, and the last property is whenever you're taking the integral of dx between those intervals a and b, you can also write it like this, right? And if you evaluate this expression, this is basically calculating the area under the curve of y equals 1 based on my given endpoints from x equals a to x equals b, which is b minus a. And it's also very easy to prove this property as well. You'll have to basically take the curve y equals 1 and evaluate the area under the curve from x equals a to x equals b. And if we try to do that in this case, let me draw it out. If you have, you'll see that if you have the curve y equals 1, it would look like this, right? Where this is my 1, and if this is a and this is b, my integral dx or integral 1 dx based on the intervals a and b is basically the area of this region, right? Which would be the area of the rectangle in this case. And the area of the rectangle in this case is base times height. Since I know that my height in this case is 1 and my base in this case is b minus a, so my area would become base, which is b minus a, times height, which is b minus a, and that is what you have on the right hand side as well. So that is why this property holds true, and we can also prove it very easily as well. So now, since we know all these properties, let's apply those properties in order to solve a definite integral expression. So as you also know that we proved in one of our videos that integral of e to the power x from the given endpoints x equals 0 to x equals 1 is e minus 1. If you have not watched that previous video, I would highly suggest you to first watch that video in order to get the context of what we would be dealing with in this video. So we already know that this result holds true, and based on this result we have to calculate the definite integral of the function e to the power x plus 7 with the same interval, with the same endpoints. So let's try to evaluate this expression. And we know about the properties of integral that I can split these two parts, right? I can split e to the power x and 7 and can take the definite integral in both those cases. So let's do that. If we split this expression, it would become integral 0 to 1 e to the power dx plus integral 0 to 1 7 dx, right? And if we further simplify it down, this would remain the same, but I can take this constant out based on this property. The third property, I can take the 7 out, and this would become 7 times integral 0 to 1 dx, right? And we already know the result of this, right? We already know that this is equal to e minus 1, And we also know the result of this as well, which we proved over here, that whenever you're taking the integral of dx from a to b, it's b minus a. So now let's calculate the final answer. So the final answer in this case would be, this would become e minus 1 plus 7 times, this answer is b minus a, b is 1, a is 0. So it would be e minus 1 plus 7, and the final answer in this case would be e minus 1 plus 7 is e plus 6. And this is your final answer. And this answer was completely based on using the properties of definite integrals that we discussed in this video. So that's it for this video. I hope you found these properties interesting, and these properties indeed give you an easier way to evaluate a definite integral. And we'll also cover some more interesting properties in the upcoming videos, so stay tuned for that. Thank you so much for watching. Bye bye.